Welcome to the Energy InSites podcast, your source for the latest insights in deep retrofits, renewable energy, and energy conservation. And now let's get to today's insights. And we're back for part 2 of today's doubleheader extravaganza with James Bererton, serial entrepreneur, innovator. This session is going to be about ETA Energy Solutions, which is James's residential and smaller scale geo-exchange and other innovative technologies. So, James, welcome back.
Thanks very much. Yeah, this is ETA Energy really acts as my research incubator. So I do all my research through ETA Energy, do the technology development, and then deploy it at the smaller scale. And anything that's really, really good or works at large scale gets passed upwards to the thermal energy, and we work together to deploy at the large scales. So what I'd like to share today is primarily the project that was funded by Natural Resources Canada as well as SORIA, which is a sustainable funder in Alberta. And it was a call toward net zero homes and communities. So the Natural Resources Canada put out this call, and I had sitting on my shelf my vision for the design, rolling out economically, rapidly deployable solutions for the residential construction industry to meet our housing demand and to do it in a way that's sustainable. Really, we want to be sustainable in all of our energy. So this concept is a factory-built, modularized home that gets put together on site in large modules and then deploys a number of different technical solutions to meet the energy demand, reduce the energy first, and then meet it with sustainable resources. So I think the best thing to do would be to walk through that slide presentation, and as we go through each of the sets of technologies, you can comment and ask questions if that makes sense.
Great. Yeah, thank you. A big shout out to Enercan as well for encouraging
without
solutions
Enercan,
like this, technologies, pilot programs. So much of Canada's innovation is related to work that Enercan does. So thank you.
Absolutely, for sure. It's the without Enercan, it wouldn't have made it. And we have other partners as well, funding partners. So I'm just going to try and get this to the point where I can share it properly. See if that works. So now you should see the full. This is the finished product, or mostly finished. I can't say finished because it's an experiment. It's never finished. We're doing multi-year analysis, but what you see here on the screen is 3 modules put together to build a residential home that is energy efficient and actually produces 3 times the energy it will need to service its 2 EVs that get charged by it. So they cover a number of different areas.
Is that still a concept, or is that the actual photo?
That's real life.
Really?
Yeah.
Whereabouts is this?
This is just west of Okotoks. So everything great gets built near Okotoks. Drake Landing got built in Okotoks, and this is just close to Okotoks. It was purely coincidental as where we could get reasonably priced land to put on a special built modular factory built home.
Okay. And let's take a few minutes at some point here and touch on Drake Landing again, as we did a little bit in the last episode. This time more on the residential and what that project meant for Canada and everything, that's all the key learnings that have come off of that and your involvement in it.
Yeah, so Drake Landing was a solar heated community, and they used borehole thermal energy storage. They had 144 boreholes, and they stored heat from the summer from a solar array to then extract that heat in the winter. But that's at a pretty large scale, and even Drake Landing was small scale for what it needed to be cost-effective full commercial deployment. So now you take that down and miniaturize it to one house what do? You can't build a bore field for one house. All the energy would leak out because it's too small scale. So what we did instead is we developed the solution. This house is on piles, so it's screw piles, structural screw piles, and in those piles we actually do store heat from the summer and we create a warm pad underneath this building, and then in the winter when it's very, very cold and your air source heat pumps don't work well, that's when we extract that heat out of the ground uh, heat bubble that sits underneath the home. That's one of the experiments we did on this project.
Is this so? A few episodes ago, I had Loie Gunnewick from SolarWall on, and he was talking about a house that was built on screw piles, possibly with a phase change material. Is this the one he was talking about?
This is that house exactly, yes. And not only do we have the energy piles, which is just circulating fluid in the hollow part of the pile, but we actually inserted inside that hollow part a macro encapsulated phase change material. We're running 8 different experiments to see,
Wow.
because they change state at different temperatures. So we wanted to see what we could get out of each of these piles. And then we even have an experimental pile inside the garage. You can take the flange off one of the piles and you can put in any phase change material solution you want and see how it works. So we can measure its performance.
So this is very bleeding edge as far as my own knowledge goes. When Loie mentioned it, it was something I had never heard of before. I think very few people in Canada have heard of this. When I've used screw piles to do solar PV arrays before. Um, can you walk us through the dimensions of that, and is that an intake pipe and an outtake pipe? You got a loop within it. What does that screw look like to hold up a house like this and then tie into some kind of manifold?
So if you think of the screw pile, it's if you've seen an auger, a grain auger, it's got that spiral
Yeah.
design. So imagine you've got like a corkscrew. At the very bottom, there's a corkscrew of metal that sticks out from the pipe, and then the pipe itself is a 5.5-inch diameter steel pipe, and it
Okay,
just
so
has that
pretty big.
corkscrew on the end. It is pretty big. We could have gone smaller, but the screw pile company we selected said, we'll do it, but only if we do these big piles, which is fine.
And
This
that's the
is an
tube
experiment.
portion is 5.5 inches, and the
That's right.
screw goes even
The
wider.
screw is like 18 inches, 20 inches in diameter.
Okay.
Um, and, and so they screw these down. This is a normal construction process for structural piles, and they'll
Yep.
screw it down. In our case, they could only go down 12 feet, and then they torqued out at 30,000 foot-pounds of torque on their machine, and it went 12 feet
Wow.
down. Now, you could go deeper in different soil conditions, but we had a very hard packed clay condition under this site, so that's how far down they could go. Now that is just what would hold the house up, and instead of a concrete foundation. So one of the features of this home is there is zero concrete. There's not 1 kilogram of concrete in the design, and the reason is it's supposed to be more carbon, a lower carbon solution. So this design is about 70% less carbon embodied in the building materials and construction than you would have if you build like my neighbor. You can see a little piece of his house in the left there. That's a concrete foundation with a basement. Well, that's where all the carbon is. 40% of a house's carbon is in building a concrete foundation. So screw
Mm-hmm.
piles, even though they're metal, have far less carbon content than
Hmm. Well, I
a
know a
concrete
lot of us
foundation.
Canadians, we love our basements, even though they're maybe not always the most practical, not the best energy efficiency. It's just that extra storage space. We really love that. But when I look at this photo, so what do you do for like that garage area? Is it
So
gravel? Do you have some other?
yeah, so that's a really great questions. I mean, we should really just step through the slides and we'll try and answer the
Sure.
questions as we go. But I will talk about the garage. So instead of building down to have a basement where no one can see out, we built up. This is actually 2 suites. The one on the left in black, that's the upper suite. And what you're looking at in the gold color that's the staircase going up to the upper suite. And then in the back is the lower suite. So instead of building up and having a basement, we built two 1,250 square foot completely independent suites. So we're trying to get some higher density. And each one has 2 bedrooms and 2 bathrooms. So let me step through what we can cover today. First of all, the construction was done in a factory built, modularized, and then craned in place on site. We have water conservation measures. We have energy conservation and sources. We have a high efficiency, advanced HVAC system. And then material selection is key to having an eco-positive design. So we can go through all those. There's that garage you were talking about.
Okay.
So it's quite a large, long garage. We could have made it a little bit wider, and we could have easily fit 2 vehicles the other way. But as it is, we can still, it's a 16-foot wide door. You can fit 2 vehicles in there, and all the mechanical systems go in the back of that garage. So
Wow.
these pictures are a little bit old. They're from the construction process. It's all complete now and has quite an advanced energy system in the back of that garage there.
And was that 16 feet wide because the modules were 8 feet wide due to
No,
highway?
the modules are actually 18 and a half, 19 feet wide. So that is the width of the module. It was 18 and a half feet. So the door is 16 feet wide.
Okay.
And the module is at 18 feet wide with the outsolation, right? So the interior of the garage, a little over 16 feet. And then we have outsolation, which you can see that hemp insulation is shown there.
Wow.
We have 2 inches of outsolation on top of the 2x4 construction. So it's not even a 2x6 construction. It's 2x4 going back a step, but then putting 2 inches of continuous hemp panel outsolation. So it's still an R21 whole wall R value. So very equivalent to your 2x6 construction.
I'm forgetting the name right now, but I know there was a couple of guys in Calgary that were into the hemp insulation. Did you get it from them?
Not exactly. So the hemp itself is actually from Grand Prairie. It gets shipped down to Idaho, and then they manufacture the hemp panels there and ship it back to us.
Wow.
But we could have that done, of course, in Alberta and Canada on the hemp panel side. And then the hemp, the other insulation we have there, what we see as bat insulation, that's not hemp, that's sheep wool. So, and the sheep wool is an even sillier life cycle. It comes from Australia, where they have lots of sheep, lots of excess wool, and then they ship that to Nevada and chop it up and put it into the bats or into chopped insulation, and that's where we got our hemp insulation, or sorry, our sheep wool insulation.
So a little rough on freight carbon, but
well, you'd think that, but
overall, like natural fibers and sustainable farming and all of that, probably okay.
Well, actually quite good. Now this is where you get into the science of it, and there's science and then there's statistics. And I think Mark Twain said something about there's lies, damn lies, and statistics. So your environmental footprint of your steel slag rock wool should be a lot higher than the sheep wool, but when they run the numbers, they give the rock wool is 0 carbon to start with instead of the very high carbon of the steel waste product, and the sheep gets the same deal, but then they have to pay for all that transport. So depending on your perspective, and this is a whole new science of how to calculate the environmental product declaration and your carbon content, but in my opinion, sheep's wool was one of the biggest successes of this project because it's got many factors. So it's an R15 bat in a 2x4 cavity, so it's better than fiberglass insulation. It's antimicrobial because sheep can't have microbes in their wool, and so naturally it stops any mold, mildew, etc. Even if it got wet, it can dry out, and it maintains its insulation value when wet.
Hmm.
Fiberglass doesn't do that. Rock wool doesn't do that. So it's an amazing insulation that I would totally use again. There's a small premium over rock wool insulation, about 10 to 15% premium, but it's a far superior, safer, more natural. And you can not only could you touch this, you could sleep on this insulation,
Right. Instead of getting the
it's
itchies.
oh yeah, it's so
Oh,
bad.
anybody who's ever renovated a house, they know about the itchies.
From those fiberglass. Well, yeah, fiberglass
Yeah.
insulation is terrible for that. So, and it's somewhat fireproof as well. So, this is our best. One of the big successes in our 34 experiments was using sheep wool insulation. The head
And
panel was also really good on the outside, but it was a little harder to work with and cut. So,
okay.
but
And the
it's
freight,
still a
the
good.
getting this, 20-foot wide mod, like this was a special permit on the highway kind of deal.
It is. You have to have permits, but
Yeah.
we kept it there. There's like 3 classes of putting these modules on the highway. And what the key is, the normal school portables are
Mm-hmm.
24 feet wide, and they set the standard for what you're going to pay to ship these down the highways, because they can either ship your module that's 20 feet wide, or they can ship a portable for 24 feet wide, and they'll charge you the same price. So yes, there's permitting. Our permitting is level 2 permitting. It's not as bad as a 24-foot wide one. The reason it's 20 feet wide, or 19 and a half, was the factory door was 20 feet wide, and you had to have
I
a little
see.
bit of
That's
room
their
to get it
limiting.
out the factory door. Yeah.
Um, the reason I asked that question is because a number of our community partners are in the north, and they, will likely need to get a lot of their new builds trucked up there, modular builds. They have a lot of ATCO trailer type buildings. And
Mm-hmm.
I'm just wondering if a solution like this could be done in your standard 8-foot width modules, so that the permitting process is
Well, I
non-existent, or standard trucks, and then still be able to bolt them together, or does that become problematic?
that's a great question, and I would pose it this way. I would feel it's more economic to build it in these 20-foot modules and pay the permitting price. The
Okay.
permitting price is actually a small fraction of the overall build cost, and you can range these modular constructions. These factory built modules can ship up to 800 kilometers from the factory. So if you think of a factory in Edmonton to reach the further north, that's going to reach a lot of the communities. And for even further north communities, it's well worth it to pay the additional transport costs to get this module shipped on site, and then the construction on site. There's still time on site. You can see the
Yeah.
foundation work has to be done, putting the modules together. Any custom construction has to be done on site, but that savings in quality control and the energy efficiency of having that done in a factory, that's a big savings. That if it's done properly, and
Mm-hmm.
the key to that is to have a well-defined product and solution. The whole design has to be the 10th of a kind, and then you do multiple cookie cutter and ship that up. What you shouldn't do, which is what we had to do, was do the first of a kind in a factory and go through all the heartaches of the design process in a factory construction setting, because that adds cost. And so for
Right.
prototyping, I would recommend you do it with the old stick built way, and then once you've got the design refined, then use the factory to ship it up.
Yeah, those factories are designed for throughput,
Yeah.
and not doing a lot of on the fly mods. So, okay, can carry on, please. You've got more
Yeah,
slides here. This is great.
for sure. So you can see lots of levels of construction innovation. Light zone glazing units. So this is the interior part of your window is the glazing unit, and we use light zone, which is I researched all the windows across the world, and these are the best. And still, I feel those glazing units are the best. And it comes out of Edmonton, Alberta. It's big surprise. It's purely coincidental. I looked at Alpine windows in the U.S. and other solutions. This is a pane of glass, and then 4 sheets of plastic and another pane of glass, and it gets you a window that's R17 and a half. It's almost as good as our wall for insulation value. And
Hmm.
the glazing units are fantastic, really great design of units, but they're also a new technology. They're not a new company. They're 10 or 12 years old, but they need the support and funding from the government to grow and get to the point where they have economies of scale, because they are premium. They're a 25% premium product, but their smaller versions are comparable to
Oh,
triple pane windows, the
yeah,
best
you
in
mentioned a
class.
premium. I'm thinking compared to what? Single pane, double
Compared
pane, triple pane?
Yeah, if you compare their middle of the road to triple pane, they can actually be lower cost. They're higher end that are 17 and a half. I mean, triple pane can't do that. It would be way too heavy, and you'd have to have quad or quintuple pane windows full of glass is impossible. So they
Mm,
can't reach that level. A triple pane window, a good one is R6, R7. You can't touch
wow.
R17. So this is much, much better technology. And it just
Okay.
needs to be brought down in cost to be competitive and scaled up in volume to be competitive. So we hope that they'll be successful in scaling up. They're working on their funding right now and financing to get to the next level, and we hope they move forward.
And are they
Um,
making these exclusively for single family residential, or do they make them
no,
for glazing for commercial buildings as
all
well?
scales, commercial buildings.
So
They
big.
were looking at an apartment complex in Calgary just last year, and they
Okay.
have a number of opportunities there and solutions.
That's
Um,
great. Well, big shout out to Light Zone.
yeah, they're fantastic, great company. There's lots of other construction things that are all listed here. I think in the garage you can see that recycled rubber mat that comes out of Legal, Alberta. That's recycled tires. That's what we used instead of a concrete slab. So
Okay.
and if you do the same gravel type foundation that you would below a concrete pad, and then you put these mats down, that's the ideal. So that could work out very well. And low carbon, recycled material, great opportunity. We got to do something with those tires. So let's go on to the next slide here. So
Is it worth touching on off gassing and VOCs within that context?
yeah, so a lot of people ask the question about what's the smell? Does it smell like recycled tires? Because that'd be terrible. Most of that off gassing occurs in the first year, and right now you walk into this garage, you can't smell anything. So there's no odor that goes with it, no toxins, etc. I'll get into the VOCs in a minute when we get to the HVAC, because then we'll talk about how we control and manage that.
Suppose it
Uh,
also serves well as a weight room to
it does, or a weight room, or
heavy mass matting, right?
well, weight room or jujitsu floor. It can do all those things. We actually had one of our workers had a stumble off a ladder, and because they landed on this floor, they weren't injured at all. So it
Ah,
that
amazing.
actually we had
That's
two workers fell during the construction, and one of them fell off the front porch. If you go back to the, let me go back. So that roof that was being done on the front porch, they
mhm.
fell just in that corner onto that rubber mat all the way from the top and were uninjured because of the soft
Wow.
landing. So that was a side effect. Obviously, you want to do
Yeah,
safety
so you
first.
don't
Don't
want that,
fall
but
in the first place, but it does happen. And if it was concrete, that would have been a trip to the hospital. So
yeah, we've
here,
seen some of those accidents, and it doesn't end well.
so here's the light zone details. You can see the four PET films in the middle, the glass, and their primary technology is their framing system. They can actually create this as a picture window, one that doesn't open. They can use just the glazing unit and just install it in your wall, seal it up, and that's your window. When they do that, they're lower than the price of triple paned windows. So we're actually looking at that as the better solution. Just have your egress windows in your bedroom, and then have non-opening windows, but add an operable vent, uh, so you can get your fresh air that you want, but you don't have to open the window just to get fresh air in. So
Wow.
that's one solution we've looked at, and we're looking at marketing that going forward.
And is that tempered glass, the outer layers?
It'll
Like, can that be
be
security glass?
Same rules. If it's within the lower 2 feet from the floor, it has to be tempered glass. If it's above 2 feet off the floor, then it does not have to be. So that's just standard rules about glazing units.
Oh,
So
okay.
they can
I wasn't
change
familiar
whatever
with that.
glass. Yeah,
Uh,
whatever glass rules they have, they can change the glass to be tempered or non-tempered. So we have a big door that's all tempered glass because it goes right down to the floor.
okay.
Let's see what else I can show you here. So this is the water solutions that we looked at. Some of them we implemented, some we didn't. So we did implement the rain stick recirculating shower. That was a product developed, actually, again, another Canadian product. There are about 3 different recirculating showers technologies in the world. This one is invented in Kelowna. And what they do is they just take your drain water, they pump it back up, they put it through a UV filter, a carbon filter, and a film filter to get rid of everything, and mix it again with hot water. So it saves 80% of the water, 80% of the energy, and meets all your plumbing codes to put
Yeah,
it back
that's
up.
really neat.
Yeah, so that's pretty big deal. It they've since gone out of business, and they don't produce the shower anymore.
Mm,
But the problems were in where they put this technology inside the shower unit itself, and they were at the point where they were starting to deploy in like an under the sink solution. And we think that would have been the way to go if they did that smaller, simpler solution under the sink. You could treat the entire bathroom, all the sinks and the shower, which are light gray water, and that would be a better way to deploy that solution. And we're looking at trying to take that technology to the next level.
great.
Um, so on the right there is a gray water treatment plant. So in Australia, they have water shortages from their heat, and they developed a system to treat the whole house gray water and bring it back to the level where you could reuse it for bathroom toilet flushing, and you
Okay.
could use it also for watering your landscape. So that is a system that we considered deploying, but it was a little expensive, and we thought, you know what, we'll wait until we can deploy our own version of it at a much lower cost. So it's about $7,000 to add that gray water system in, and that just
Hmm.
didn't make sense. For it was the 35th experiment, and we said that's a bridge too far. Um,
Yeah, I remember a condo project in Bridgeland in Calgary years ago. It was the Aqua and the Vento. I think it was Windmill that was doing it, and they had a really great idea to do rainwater collection for flushing toilets and things like that. And I remember it having some controversy because they weren't allowed in the end, and they essentially had to do significant water filtration out of concerns that some kid's going to drink out of the toilet bowl or something, and so
yeah,
they had to
it's
do
a
like, I
pretty
think it was reverse
strange.
osmosis or UV
Yeah.
or something for the whole unit. And I don't remember the details as to whether they skipped it or did it. um, but I remember the developer being a little bit flummoxed by this new hurdle they had to jump through.
Yeah, our water regulations in Alberta are some of the toughest, and the water authority doesn't change very quickly. So this technology was approved in BC and Ontario. So apparently it's safe for them, but not safe for Albertans. But we're working on that. So in Jasper, they did one of these systems, but that Jasper is actually federal, not
I
Alberta
see.
regulated. So,
Yeah,
but it is possible, and we want to work with the water authority to prove out technologies that work, but are also cost effective. So neither of these two technologies were cost effective, but they were proof of concept to show it can be done. It is certified. It
right
does
on.
meet water authority regulations in other jurisdictions. Now, how can we make it make sense? Because it's got to be economic, or nobody's
Yeah.
going to do it, and you won't
Well, and
have a
it's
company.
it's understandable to want to keep everybody safe and want to make sure that like
100%.
Canada has some of the best drinking water in the world overall. It's not without its challenges, but I do hope that for any of those policymakers listening, that gray water systems, rainwater catchment systems, that we help work together with industry to find ways to allow for this to be done safely and cost effectively at scale, because it does have tremendous benefits if we can find the right balance.
Well, and that's on our research roadmap. As I said, ETA Energy, this is the research arm. So we've got partners who work in water treatment, and we want to extend this. If you can reduce the amount of water your home is using, you can make a smaller water treatment plant. And especially for northern communities, op- operating and building those larger treatment plants is a huge cost. And it's one of the reasons they don't have good water up there. If we can build it into smaller components that are right in the home, that are all pre-tested at the factory, then that's one way to provide good, clean water and reduce the amount of water and requirements for those communities up north.
That's a great idea. Yeah, for sure. It remains a persistent problem that one would have hoped would have been solved by now, but there's obviously a lot of lingering reasons for it, and scale, cost, usage, rules, all contributing.
Operations and the complexity of the operations, those are things that need to be
Yeah.
solved. And this is partly, we're trying to make these the solution set that we have here. If you look at the future ones, we've got zip grow towers for greenhouse. So we take that wastewater, we use it to grow plants on the rooftop of these
Mm-hmm.
buildings. 8 of these structures would provide all of the vegetables for the entire city of Okotoks if you use zip grow towers on the rooftops.
Wow. Yeah, I know those guys from years ago. They're out of Cornwall, if I'm not mistaken.
Yeah, and there's
Yeah.
Leif Fossheim out of Lethbridge is our greenhouse guru, and he's the one who recommended the zip grow towers. And that would be on the next version of this. We would deploy those on the rooftop, and it's all in this closed circuit water cycle. So you add tilapia fish in an aquaponics. That water goes up to the zip grow towers, and then eventually out of the zip grow towers it gets treated, and we can actually have black water treatment in a bioswale. So our we didn't do that here, but that was be the plan for the future. What we did do is like a level 3 treatment of the wastewater that comes out. Technically, we'd be able to put that right onto the field, but
Hmm.
regulations being what they are, we still have a full septic field where the wastewater goes out and is kept under the ground and not into the
Okay.
flowing
Yeah,
surface water.
haven't seen anybody scale down pyrolysis units to being a residential scale biochar manufacturing off of your water treatment,
No,
waste
I haven't seen
sludge.
that scale yet. And in
But
fact, we
that
did
would be
look
an
at that.
interesting one.
The Cinderella toilet is the equivalent of that small scale. It's Cinderella because it's a
Oh,
cinder
okay.
toilet. So that one, but the cost to run that in electricity was so high. It's 10 cents a flush, effectively, and
Yeah.
that was too much. So that was considered but not deployed.
And composting toilets, though great for RVs and off grid,
I don't know. I
not
couldn't.
haven't really found a home in the urban
I
environment unless you talk to Jorg Ostrowski out of Calgary. Shout out to Jorg and some of the innovations he's done. But it's been pretty edge case stuff so far.
Yeah, edge case, I think there's a stigma attached to it. And unless you really treat that well, you can't have any odors in your regular home where people won't accept it. So, yeah, for sure. So here's some source energy. We didn't deploy the single axis trackers yet, but there will be some ground mounted single axis trackers. We did deploy the full 6.35 kilowatts of PV thermal collectors. So that's where we get all the energy for the home at this time. And it's not just electrical energy, it's also thermal energy. So during the summertime, we collect off the backside of the PV thermal collectors and we store that into the base of the house. So in the bottom left picture, you can see those piles, and we
Mm-hmm.
circulate water into those piles and we take that heat and we're warming up the entire footprint. It's an 1,850 square foot footprint with the lower module and the garage. And that entire mass of earth is going to be heated up. We're hoping to get to 30 degrees Celsius by the end of summer. It will leak out because it's small scale, but it'll still be warm enough when we get to the peak of winter that we don't have to use our air source heat pump taking heat from the air. Instead, our dual source heat pump will take heat from the ground underneath the building.
Amazing. So Lowy Gunnowick was right. and,
That's for
and
sure.
and is that so? Those screw piles are they? they're insulated outside on the outside, so they're inside that insulated kind of perimeter,
So what we did
or
for
each pipe is insulated.
No, they're not insulated at all because we want to actually communicate the heat to the ground. So they're insulated now. The top part is insulated, each pile, but under the ground, we want it naked to the ground so it'll communicate the heat to the ground. What
Okay,
we
so
did,
you're not trying to contain your heating and cooling area under the ground. You're not doing like a perimeter of rigid foam or anything like
well,
that.
we did actually exactly that. What we did is to prevent the winter cold from taking that heat away rapidly. We
Yeah.
have a 1 meter perimeter of horizontal insulation. And if you think of that, it's a little over a meter. You think of that, well, that's that much earth insulation to where the active piles are. So that
So
amount of
one
earth is
meter
quite a lot of insulation.
horizontal, but then
Yeah,
how deep?
we don't go deep at all.
Really?
Uh, we don't have to because 1 meter of soil is a very good insulator.
I'm so you have a rigid foam going horizontal
Horizontal.
at the
Yep.
1 meter mark, so 3 feet down.
No. It's on the surface.
It's
We
on.
want to use
Okay.
all that soil volume, but because we're active only a meter in from the perimeter, we effectively, for our thermal store, have a meter of soil preventing loss. So there will be losses, and that's the problem with storing heat at small scale. We don't have the scale of a Drake Landing with 52 homes worth of ground storage, so we can't get that volume to surface area efficiency. We know we're going to lose the heat, but it was waste heat to
Hmm.
begin with.
So,
And we're only using it in the peak of winter.
and forgive me because I'm just trying to visualize. So, around the perimeter of the building, you've got a rigid foam. Is that correct? And
Yeah.
it's a meter
Let me
wide and maybe how many inches thick and how far below, like right on the surface, like you could step on it, or it's underneath some
do,
gravel, or it's part of the slope and the drainage, or how?
do you see the perimeter walkway that looks like recycled rubber mat around this
Yes.
picture of the home? So underneath that is our solid rigid foam insulation.
Okay.
We put it in primarily for the structural reasons because we can't have our piles we can't have the ground frost heave. The piles will keep the house at a certain level, but if the ground heaved up from frost, then we would crush our skirting wall. So that's the reason we have that insulation primarily as a structural reason, but it acts as doubly as the insulation to stop heat from leaking out from that
Okay. And
pile
how
system.
much is there? How thick is?
It's only 1 inch thick, plus the rubber mat as well. So the
Okay.
rubber mat is 1.25 inches, and so it adds insulation value
So
as well.
extremely modest R value.
It is, well, that's our six. It's almost our 10, and it's
R10? Okay. Just
just to
enough.
stop, just enough to slow the loss of heat because we
And
know there's. Imagine a big thermal bubble like a balloon blowing up of heat underneath that
yeah.
footprint, but it's 10 times what we need. We only need to make it through the coldest month of temperatures in winter where we don't want to use the air to be our heat source. Our heat pump is a cold climate heat pump, operates down and proven to minus 25
Mm.
Celsius, putting out over 50, over what is it? 60 Celsius is what it can
And
put out at minus 25.
wow, and you're getting a ton of heat coming off of those panels, those collectors,
We get the heat off the
all
panels with
year
the heat.
long, I'm assuming.
That's correct. And this is a custom designed heat pump. We took an air source heat pump, modified it to be able to do water to water, and that way it can take the heat out of the solar instead of out of the air whenever that's more efficient to do so. And so we actually have it's a patented, patent pending process where we can put those in series. And so we take what we can from the air, and then we top it up with the heat from the solar thermal collectors.
Amazing. And the ground is your battery.
Ground is one of our batteries. So we have the ground as a battery. On the bottom right, you'll see a phase change material storage for domestic hot water heating. That's our hot
Right.
water storage.
That looks like the
And
sun amp.
It is the sun amp. Very good catch. And then we are making our own larger scale, medium term storage. And the reason we have all these different thermal storages is we're trying to determine what is the most cost effective. Should you put the piles in the ground? Should you drill a single borehole for a house? Or should you put in a small tank? And especially in the retrofit market, we can bring in a tank. We've got a 1.6 cubic meter tank, and it could last the house 5 days in the peak of winter. Well, if you only need 5 days, then that's the way to go. And you don't have to build a fairly expensive pile network or a larger cost for a borehole. And so we're trying to work out what is the right combination of technologies to deliver at the single family residential scale for new build and for retrofit.
Amazing. This is really, really interesting. And so were you able to get that Sun amp directly from Sun amp, or did you go through
Yes.
one of the guys here?
Nope, I got it directly from SunAmp. We're promoting their technology and demonstrating its use
Got it.
cases. Yeah, so we got it direct from SunAmp.
And if I may go back to the screw piles with the glycol loops in them for a moment. So
Yeah.
is that just an aftermarket PEX line that you've run in and out or something? Like what does that look like to
Yeah,
loop the
that's a great
glycol through
question.
it?
So we worked with our piling contractor, and they have some custom welders, and all they had to weld was 2 ports. So they welded 1 port at the top of the pile, and that just goes direct to the 5.5 inch diameter. It's basically a pipe. And then the second port goes inside the pile and does a 90-degree turn pointing downwards. And then we attach a 1-inch PEX tube that goes down the center of the pile. And what we do is we pump water into that tube, goes down to the bottom, and comes up what the space in between is called the annulus, and comes out that sidewall port. And that's how we circulate water and transfer heat into the ground.
And it's capped at the top.
It's all, yeah, those caps, you can see them in the picture. It's just a solid metal cap at the top. A little bit of lessons learned there. Do your welding and your water tests before you put the rest of the house on.
Right, under pressure.
Because there were a few piles that failed, and we had to have them come back after the house was on top and do the welding to do the repairs. That was a challenge.
Makes sense. But you're running water through that or glycol?
Correct. Just water because we're always keeping it hot. We want to aim for 30 degrees at the end of the charge cycle and bring it down only to 5 degrees.
And so the water's hot and the whole ground area around that pile is hot.
For sure. And
Or at
the
least
whole ground
well
area
above
around the
freezing.
house, well above freezing. We cannot have freezing near the footprint of the house because that would cause frost heave. So we avoid that by dumping the seed in there and
how
never
many
taking it out.
days in February of -30 in Alberta of a power outage would it take before this system would self-destruct?
Well, that's a great question because the way we mounted our solar array on the side of the house is at a 60-degree tilt. And what that does is it favors winter generation. And so our difference between the peak in June and the peak in December is only about 10%. So we actually have very similar solar output in the middle of winter, in the darkest days of the year. In addition to that, we have 32 kilowatt hours of house battery storage. So with the time when the sun isn't shining, we charge up our house batteries. This house can actually go completely off grid year round. So there won't be any number of days that would break this creature.
Wow. So it would take more than just a long duration power outage. It would also take like a hurricane or a tornado,
a multi-system
you
failure,
have other problems
in order for it to not work.
That's
in
amazing.
addition to that, we plan to have bidirectional EV chargers. We're working on getting those. And with that, you could even take your EV away from the house, go charge it up, bring it back, and survive some natural disaster where the power was out in the dark for a long period of time. But in theory, we wouldn't need that backup because we have the system designed with the electrical storage to last through the darkest days of winter.
And I'm assuming this house is grid connected, correct?
It is. Grid connected is the best.
And so with your solar PV portion, Do you have certain switchgear in place so that if the grid goes out, the solar can still be generating for the house?
Yeah, we're completely islandable, is what you're describing
Yes.
there. We can act as an island. Whenever the power goes out, we do need to still protect like in an emergency, when they pull the breaker at the side of the house, that shuts down all production. But if there's a grid failure and it knocks out, we isolate from the grid and then still reconnect and generate our own power from the solar,
And
so
does
we can
that
island
happen
load.
automatically instantaneously, or that's a manual switch?
We are using the SolarArc inverter that handles all that automated transfer switchover. It handles the EV charger and it handles the battery charger. So that is our inverter central power plant brain that handles all of those functions. And then on top of that, we have safety controls on the individual PV modules to ensure that if there's a fire or fire department needs to act on it, then they can be disabled, so there's no high voltage risk to the fire workers.
Amazing. And do you have the building set up on on like a critical load sub panel so that you're just making sure that you're basic, or is it able to do everything?
It's full load, so there's no
Wow.
sub panel. We do the full load.
And that's
That's how we
because
do it.
this building is so efficient in so many other ways that you're able to pull that off, or you just oversized it.
Well, it's quite efficient. So from an electrified energy point of view, it's very efficient. Once we have all the control algorithms written and all the systems fully commissioned, then yes, we'll be able to sip away at that electrical profile. But yes, we've built up not just to handle the load of the house, but we will have enough solar to feed two electric vehicles for 15,000 kilometers a year, your typical utilization for a vehicle.
Amazing.
So
So that brings up a question I have. When I've looked at net metering before for solar projects, um, the utility companies often have policies around capping you at somewhere, let's call it 110% of annual consumption. And the reason they give you the extra 10 is because of the degradation curve of solar over its life. And so you're allowed to slightly overspec it. But they're trying to, they're not really incentivizing or wanting you to grossly overgenerate such that you're like selling wholesale back to the grid. So how did you get around that? Was this a special permission
no,
to kind of oversize the system, or is it because of the thermal combination that it's still skirted under on the electric side, or
no, it we worked within those limits. I don't agree with those limits. There's no reason at all for them. If my neighbor's house is a negative draw on the grid all the time, which because they don't have solar, they are, then why shouldn't the next door neighbor be able to produce twice as much? There's no reason at all for that. That is a purely regulatory barrier that makes no sense. That's just to preserve their revenue streams. But we fully complied with that philosophy of 105, 110% because we have two EVs that are required to be fueled electrically by this house. So from
okay,
that perspective, we can have a massive PV array on the house and larger scale, larger installation, that's more cost effective. You come out once with your solar install crew and install 19 kilowatts. Well, that's a third the mobilization of doing that three times at 6 kilowatts for three houses. So having the two EVs in there, you have to have the EVs fully registered to your name, address allocated to the house in order to get permission to meet that. Yes, we will do
very
110% of
very
our
interesting.
consumption.
So pay attention, everyone. If you're looking at doing your house in solar and you want to go bigger, get yourself an EV and register it correctly, and that gives you a little
That
extra
opens it
pop.
up. An EV is about 4,400 kilowatt hours per year doing that 15,000 kilometers. And that is about, depending upon how energy efficient your house is either double or 50% more energy that you need to feed that EV. So I've seen houses that are only around 4,000 kilowatt hours a year, and I've seen less efficient, same size house that's 8,000 kilowatt hours a year. So you can see how an EV is about, it should be the size of your house in terms of an electrical requirement annually.
Wow. I had not considered that before as a workaround or another load to be able to add to the mix, but it makes perfect sense.
Well, we
Um,
also have the heat pump, right? So we have a heat pump doing heating and cooling. So we had a big electrical load as far as they were concerned. You've got that heat pump. They're like, oh, that's going to use a lot of electricity. Now, they didn't know that we're going to do it very efficiently, store the heat from the summer and have a super efficient winter heat pump. But that's, you know,
and have you
it's all in the
also
calculations.
tied this house into something like Solar Club or one of those utility programs where you're able to get a premium on
Yes,
your
we
net
could.
metering rate?
Yeah, we can do the premium where you switch in the summer and you get to export in the summer. We're only slightly better in the summer, but it'll be more. And you can export at like 35 cents a kilowatt hour, and it's 8.2 cents when we're bringing power in the winter.
Right. So have you been through a season with that yet to see how that plays out?
Not, no, we didn't have the solar fully operational till late in the winter. So we're just now entering the summer season, and we don't have all of our ground mount solar yet. So we'll like to install that as well. Right now we're probably net positive, but just barely. And we do have our EV sucking away on that. So it's we need a little more power. We were supposed to install 19 kilowatts, but that's just the limit of our inverter
Hmm.
and what we could get away with that 110%. But we probably only need 9 to 11 to actually be net zero with two vehicles. So,
Okay. Well,
um,
yeah, carry
let me
on.
go to the
Thank
next
you.
step. So this is our heating and ventilation systems. So you've got the dual air source heat pump there with the two fans. So we converted it to be able to take heat from the air and the water. And that allows us to take heat out of the ground, put it back into the house. But what's really interesting is that HVAC system on the right. And what you see there is just an ERV, that Atmo ERV is the center of the picture. And then you've got supply and exhaust there of outside air on the left-hand side. And then you see the little drop down. I'm not sure you can see the mouse or not. Let me know if you can. But that little filter box that just drops down there, that's a MERV 13 filter. And there's a little bypass damper that says if it's smoky outside and you don't want to use outside air and you want to get rid of the smoke particles, we'll close this damper. We'll put your whole house into a recirculation mode and filter out those smoke particles so that even if you're asthmatic or you have issues with smoke in the summertime, sorry about that, just getting a call on my phone. But
Hmm. No problem.
so we filter out the MERV 13 and we take all those smoke particles out. It also works with pet dander, etc. And then we can open it up when it's regular. So shoot, there we go. But beyond that filter is we have a UV light. So this was out of the COVID days, and we wanted to have the ability to reduce virus particles in the air.
Wow.
So that's part of, we can recirculate the whole home. If someone has a sickness of any kind, we turn on the UV light. And there's actually research being done at the University of Calgary to be able to detect virus particles and have that as the automatic control for that UV light.
Amazing.
So let me see what else I missed. There's humidification, and there's a post-heat heater there, electric heater that makes sure in the deep of winter you maintain a comfortable air temperature going out. But all of those controls are all automated based on an indoor air quality sensor. So we sense VOCs when you're cooking. We sense smoke particles. in the future, we'll sense virus particles, we sense humidity and temperature. So we control all of those things and do just the amount of fresh air and recirculation mode to keep all those within safe, comfortable norms. So that's an advance in, this is basically surgical suite level of air quality control in your home.
That is a very sophisticated system.
And part of our next steps is to package that system up so there's only just two components and pop in, pop out options for the MERV 13 filters, the UV light, etc. And so that'll be a unit that is basically an enhanced ERV unit that is just has your two inlets and outlets and does all that control, filtering, etc. And we've already got the ERVs with the UV lights and the MERV 13 filters that do the particulate filtration, and we'll have these systems productized and packaged for the next generation of homes.
That's amazing. Well, certainly a number of the communities that we deal with have wildfire issues, and it seems to be more and more persistent every year. So, starting to integrate systems like these into homes is going to be hugely valuable. It's going to save lives.
Save lives, and for those people who are allergic, it handles those issues as well. So, and health is always a concern, right? So you've got 4 or 5 people in a family, and you've got all these viruses floating around. This allows you to clean that out and not spread the contagion. So that's the COVID features there. Let me see if I missed anything. Oh, one thing that's really important is that fan convector in the upper left. We use a purely hydronic means of transporting heat and cooling throughout the home. What it allows us to do basically inside that fan convector is just a coil and a blower. And so it blows the room air across that coil and can transfer heat or cold to that zone. And I mean that zone because we have 6 different zones in the house. Every bedroom gets its own thermostat. The living area gets its own thermostat, and you can individually control your zones. You can have heating in one, cooling in the other. These are things you don't have in a regular home at all. And it's minimal amount of air circulation. You don't have a huge furnace blowing hundreds of CFM around. You have just enough airflow to heat and cool the space. So that's part of the
Okay.
tricks on the HVAC side. And here's a little bit about what
Oh my
this is
goodness.
mid-construction of how we did the distribution systems. You've got the electrical on the left-hand side, our 2 house batteries, so it's little R2D2 units there.
Yeah.
That's 16 kilowatt hours each of house battery. On the right-hand side, you can see the 4 little black dots on the Thermino. That's before it was actually installed in place. And this is a good picture mid-construction because you can see in the bottom right of the picture there is the flange for our test pile. That goes down 12 feet. That's your exemplar of a structural pile, and we can put different phase change materials in there. So this is a mid-construction point of view of where we were at, but it does show a lot of the systems that go in here. Now there's a big 1.5 cubic meter tank of water in that space, but we're planning on moving that outside and burying it in the ground because we feel that's the way to go for retrofit. Bury the tanks, your thermal storage tank in your backyard, and we think we can get a month's worth of winter heating stored in about 3 cubic meters in the backyard.
And that thermal storage tank is filled with just water or
Well, we'll be running
insulated or
experiments. It's
yeah.
insulated. It's water right now, but we will be putting in encapsulated phase change materials inside that tank to extend and increase its thermal capacity. That's part of the experiment because what if you don't have any space? What if you're in a townhouse or condo unit and you need to just put it in your basement in your furnace room? Then you're
Right.
going to need the concentrated energy of a phase change material. It holds 4 times the thermal energy of a water tank. So it can be much more, just like that phase change material tank on the right there.
Yeah.
That's a 160 liter equivalent tank, but it's only 40 liters big.
Right.
So
Yeah, I'm fascinated with phase change right now and super excited to see where that goes.
let's see. And so this is our dual air water source heat pump. This is a selection. So we worked with a Chinese manufacturer and had them modify the unit at the factory in order to make it work with water to water as well as air to water. It's a great little unit. Well, it's not that little. It's a 5-ton refrigeration unit. Certainly enough for any large size house. What we said is, look, we'll just do the one unit size. One unit fits all. It'll do the big house and the little house, and away you go. Um, and we got a really good price on this, and we're still working with that manufacturer to now make those modifications part of a special new model of unit that we can sell for the residential market. And then what we'd like to work with them on is doing a 500 kilowatt version of this for the commercial and multi-unit residential market.
James, I'm sorry to interrupt. I've got a special guest here that I
Okay.
just, my daughter's just popped in. She's just on her way out to an appointment. Is that right?
All right.
I believe so. So I just want to say goodbye.
Yeah, of course.
And I'll see you. Love you. Sorry, thanks.
That's the right priority. That's what we're all about. We're doing this for our families and for our communities. So that's what we should be doing.
Yeah, absolutely. That's Skylar, my youngest, and she is very eco-conscious, very savvy, and certainly keen on some of these things, although they are a little over her head at this point.
It starts with that education about energy at a young age, and then they move into careers where it won't be over their head and they'll be blazing the trail for the next generation.
Yeah, that's my older one. The AI, the AI police.
Yeah, we've got those too.
All right.
So let me see what else can I'm not sure how much time you have left, so I want to make sure I'm fitting
I
within the
think
time.
we've got to wrap this up. So I don't know how many more slides you've got. We might have to turn this into a 3-parter after all, because I do think this is very, very interesting information, and I want to make sure that we give you the proper amount of time to go through it all.
Yeah, and we can stitch that together in the editing process too, so we can trim it down to what's concise and palatable. There's a lot going on in this house, and one thing I can offer as well is we can give tours, so you can see the house in action as it develops and the experiments as they run. So, and maybe we could do a video tour. That would be interesting. Let's see. I think I've talked about most of these things except for maybe the charred wood siding. A lot of we used a lot of wood construction because that's got low carbon materials. The shosugiban or charred wood siding in Japan, they have this siding lasting 500 years. We did an experiment using a local constructor, but they were not as familiar with the process and didn't construct the shosugiban in the proper way. We probably should have stuck with the Japanese product, and that was a lesson learned there. But it is a good solution for low carbon siding. We also have a really cheap metal siding that, although it's metal, which is high carbon footprint, is just super durable, much better than the fiber cement siding or even regular wood siding, and that was a really big success. It's about knowing where to spend your carbon budget, and there are some things that you can go ahead and spend your carbon on, like the metal piles. We spent our carbon there to get 1/4 the amount of carbon of a concrete foundation, and at the same time, the siding, we would spend money on that metal siding. It was a great product.
Yeah, well, kudos to you for doing all that math, because a lot of people don't do the embodied carbon math, and
that was a whole
it does
project
make a big
itself.
difference.
So we hired
I'll bet.
University of Calgary to do that, and they did a great job. It was a good exercise working with them.
And that wood siding product that's charred, I've heard really interesting things about it. Certainly from a rotting and mold and mildew perspective, it would be head and shoulders above regular wood. What about from a fire resiliency standpoint? Does it make a difference?
It does. It's maybe a 50% improvement in the fire rating of it because it's already burned, so you can't burn it again. It's a double jeopardy on that. So it's
But I would
actually
think at a
better
certain
than
point it kind
regular
of
wood.
ignites like charcoal would, or
It's not fully burned, of course,
Right.
and it will still burn, but it is more resilient than uh, just wood siding. Um,
Okay.
Not as good as the metal siding. Let's put it that way. One of the
Mhm.
things I didn't mention about the piles, it was inspired by the High River flood in 2013, and the building up on piles. The entire 4-foot foundation is all waterproof materials, so that this building could flood up to 4 feet and not really be damaged. You would just, the water would drain away, the insulation would dry out, and there'd be no issue with the foundation at all.
So, and it's a little, forgive me, it's a little hard to see the slide, but that garage,
Hmm.
so your wood, your stick frame wood is actually starting 4 feet up.
That's correct. It's metal studs in the lower 4 feet. You could see it a little bit on the left.
And
Those are
then the
metal
infill, the
studs.
infill is your sheep wool.
That, yeah, we switched from, we were going to have rock wool insulation at that level, but the sheep wool itself is actually as or more water resistant than the rock wool, and it maintains its insulation when wet. So
Mm.
we wouldn't lose insulation value even if it was flooded, and when it can dry out naturally, and there's no issues with that.
So
So
essentially a non-combustible metal pony wall on top of the
exactly.
screw piles for 4 feet, and then another, like a, what is it, like a rim joist, and then your regular stick frame above that.
We actually put the piles up in this case. I might change the design next time, but the piles actually come up out of the ground 4 feet, and the metal
Oh, okay.
studs are in between the piles, and the piles support that rim joist all the way around the perimeter. That's
Oh,
correct.
okay. Okay.
Yeah, that's how we did it.
Great.
It was a bit of a challenge because there's some wind moments on there. The structural engineers were very concerned, so we had to make sure that it wouldn't blow over. And the piles 4 feet above the ground have a lot of leverage on them, so we'd probably do it a little differently next time. But that's the idea, right?
Okay.
It's
And
all the
then
materials.
sealing that to the ground around the perimeter. Um,
That green plastic you see there is
yeah.
it's a rhino poly. It's like 6 millimeters thick or 10 millimeters thick. It's super thick, and that goes under the entire footprint of the building, and that's our seal from the ground.
Okay, and it's a sort of as it goes around each screw pile, it's a
No, it
fancy
goes up.
tape, or
We create it's like a pool system. So it goes up the side, and then it's shiplapped with the membrane from the
out to
wall.
the outside.
No, to the inside.
Oh,
It's the
okay,
interior. Yeah, so we have an interior membrane. So our zone, our airtight seal is on the interior of those studs, and the interior that membrane goes down over top of the green floor rhino poly, and that's how we keep it all sealed, airtight.
okay,
Yeah.
great.
And I think that's there's not too much more to cover there. Where we spent some of our carbon, I talked about the metal siding, the metal wall, mechanical system is a lot of our carbon footprint. So I'll just skip over that. Lighting, we didn't even get into our fancy lighting. So
Oh, cool!
uh,
You got color changing LEDs in there.
yeah, color changing LEDs. It's all DC lighting. It's all controlled by Zigbee.
Okay.
Um, that was one of the challenges. Actually, Zigbee integration was a problem. We're still working on it, but there are lighting systems that you can do 24-volt DC lighting throughout,
Mm-hmm.
and we have no switches wired. There's no hardwired switches. It's all wireless, and that in theory would save on your wiring costs in a future design.
Okay.
So.
Yeah, I do think there's a lot of value in the 24-volt DC systems. It's very rare, unless you're in an RV or a boat or something. But certainly an overlooked aspect of health and safety and cost. You know, the EMF frequencies and things that a lot of people don't. Some people on the more fringy areas are very in tune with this, but the average person, I don't think they understand the differences.
Well, the key was with the solar energy coming in as DC power, and we put it right into the batteries. We have no transformation losses going to our lighting. So we have as many DC loads as we can in the house,
Right.
lighting being the biggest DC load, and that makes a huge difference for, well, it's not huge. I mean, it's 6 to 8% transformation
Yeah, but
losses.
that's
So
the last that's like the last mile of gains that we still have available to us in solar, is cutting out the inverter altogether and getting more DC loads.
yeah, and if we can do that, if we can manage that, yes, we'll do better. And why
Are
not? You can have DC lights, so do it.
Yeah, and so do you still have an inverter for your traditional plug loads?
We do.
Or
The Solarc does the inversion from DC, but because it can handle DC direct to the batteries, it can also do conversion of the high voltage DC from the solar and bring it down to the voltage level required to the batteries without requiring the inverter or AC to DC conversion.
Wow. And I know a lot of cell phones and laptops and computers are actually DC. Of
Yeah,
course,
they
that's why
are.
they all have the power block plug adapter that's really your transformer. So, is there a scenario where you're able to just go DC direct with your laptop, or does that they don't?
So it's interesting you mentioned that because what we have is 24-volt DC distributed throughout the house to do the lighting.
Yeah.
And because we have that 24-volt DC, we have some small elements like tablets that we have for controls on the wall. And that is just a conversion from 24-volt DC to 5-volt DC, which is what your phones
Yeah.
operate on and your tablets. And so, yes, we do have that direct powered by the DC system. What we didn't do the laptop, you need a special laptop outlet, but a lot of laptops now use a USB Type C for
Yes.
their charging cable. So we could actually install higher power outlets that do 60 watts, which is enough for today's laptops to be
But
charged and
still be
powered
a DC.
and still be pure DC,
And
60
would
watts
that
at
be
5 volts.
24 volts or something else?
No, it has to be 5 volt. That's how,
5
because that's
volt.
the USB Type C power.
I see. Okay.
Yeah. So, but there'd be conversion from 24-volt DC to the
To
5 volt
5. You'd have a little bit of a
high
loss
power.
there, I guess, but not
Oh,
much.
but it's DC to DC, so it's
It's
very small.
very, very
Yep.
small.
Yep.
Yeah. Wow.
Yep.
That's really, really cool.
That's next level, what you're talking
It,
about.
yeah, well, that's
Yeah.
what we do here at Energy Insights. So,
Yeah, for sure. Yeah. And we
or at
will.
least we try to. Uh, so, thank you. Thank you so much, James. Are there is there a couple more? Okay, there's a nice
Oh,
photo.
that's just a photo of it getting put into place with the truck and the cranes. I don't think I have a crane shot here, but I certainly have videos on all that. Oh, there's a video of the flyby of it going into
So the
place.
$1 million question, um, you know where I'm going with this. How much are we paying for this? How much of a premium? I know this is a pilot. This is a one-off. There's, so many things here that are being proven out. So everybody listening, don't judge too much by this. But is there a pathway to making this the next level of affordable housing in Canada?
So the pathway, because it's a research and pilot project, I wouldn't take the costing. And don't forget, we put in, like, if we had one problem to solve, we put in 4 solutions for the same problem in the same
Yeah.
house. So you would never do that in a practical situation. But what the intent is to find that solution set for each level of scale, and for each, whether it's retrofit or new build, and to do that. So whether it's a factory built home, whether it's a stick built retrofit scenario, we're going to take the systems and solutions, determine which set works for that, and then we will provide the life cycle cost, lowest cost, optimal solution. And that's what we're aiming at. So I wouldn't take numbers from the whole cost of this build. This is a living laboratory, fully instrumented to research grade instrumentation with 5 solutions to every problem. You're not going to do that, but take the 3 solutions that solve all your problems at the retrofit scale, and that's what we're going to package up and build out so that every builder could deploy that solution for their homes, or every mechanical contractor or whatever the installation solution is, we will do that. So that's what we're after with this experiment.
Well, James, I just want to thank you again for this epic doubleheader that we've had today. We've covered a lot of ground, from massive commercial scale opportunities in underground thermal storage to this incredible pilot project home in Alberta. And so, for anybody who gives Alberta a hard time, please do think about this before you continue doing that kind of narrative, because they're innovating, they're leading, they're demonstrating, they're doing the work that all of us could learn a lot from. And I always loved the entrepreneurial pioneer spirit of Albertans. And this is just one more example of it. So thank you so much, James, for doing what you're doing and being a guest today on Energy Insights.
Thanks very much, Kevin. Glad to help and share.
All right, we'll pick this up again and get a follow up in the next few months.
Sounds great. Thank you. Take care.
Thank you. Thanks, everyone. Have a great day.
Bye now.